Hello students, welcome to Sanjay Joseph sir's class. We are studying chemistry and basics of chemistry. You know, you should leave your book aside and first go through all the videos of basic chemistry. If you are a beginner, we can also call it as chemistry for beginners, and we should continue to look at these videos. This will help us to complete the portion from 7th till 10th at one go. Portion of chemistry at one go. So children, we have studied about bonding, about electrovalent bonding and ionic ionic bonding, and we have studied about covalent bonding. In electrovalent bonding, there is transfer of electrons from an electropositive element to an electronegative element. More correctly, from the atom of an electropositive element to the atom of an electronegative element. Similarly, the covalent bonding means sharing of electrons among normally atoms of non-metals. So here we go to understand now how to write formula. We have got a lot of problems when we write formula, like suppose we talk about sodium chloride, we write NaCl, but when we talk about zinc chloride, we write ZnCl2. When we have to write aluminum chloride, we write AlCl3. So actually, how first we should know the reason why we write like this, and secondly we will be able to write the formula by just knowing the names. So here we go. But little basic understanding once more, a little bit of recap about electrovalent bonding. Suppose the bond formation is taking place between aluminum and oxygen. So aluminum has got 3 electrons in its outermost orbit. To complete the octet, it needs to throw 3 electrons, it needs to lose 3 electrons to some electronegative element. So oxygen is willing to take electron, 1 atom of oxygen, but however will need only 2 electrons. Therefore, what aluminum can do is, maths come, it has to lose 3 electrons, it has to gain 2 electrons. So if we lose 6 electrons, 3 atoms of oxygen can gain those 6 electrons, each one getting 2. So what happens? This is the way the bond formation will take place. 2 aluminum atoms will come, and 3 oxygen atoms will come. So this aluminum atom will lose its 2 electrons to this oxygen and 1 electron to this oxygen. This aluminum atom will lose 2 electrons to this oxygen and 1 electron to this oxygen. So this oxygen will have totally 8 electrons in its outermost orbit, 6 plus 2. This will have 6 plus 1 plus 1, 8 electrons in its outermost orbit. This will have 6 plus 2, 8 electrons in its outermost orbit. And aluminum obviously has lost all its 3 electrons. So it will have 8 electrons in its outermost orbit, and this will have 8 electrons in its outermost orbit. When the aluminum atom will lose electron, then 3 electron means each of them will have 3 charge, so 2 aluminum atoms, and there will be 3 oxygen atoms, each of them will have 2 negative charge. This now they have become a radical almost, isn't it? So now what is happening is that, have a very good look over it, they have become ions actually, they have become ions now, aluminum cation and oxygen anions. Now what will happen? So we can write this formula as Al2O3, and this is also the concept of electrovalent bonding, complete transfer of electrons from an electropositive element, from the atom of an electropositive element to the atom of an electronegative element. For little bit idea about electrovalent bonding, you can go back to my videos. Now have a look nicely. So aluminum oxide is formed. Now all the time you don't have to process this, about the formula or knowing how the bonding has taken place. In day-to-day chemistry, we should know the formulas correctly, and therefore here I will tell you how this formula can be written if you know the valency. Now what is valency? Valency is the number of electrons lost or gained by a single atom. So valency of aluminum, a single aluminum atom loses 3 electrons. So its valency is 3, and it is a positive radical because it loses electron. All those which lose electron are positive radicals. All those atoms or group of atoms which lose electrons are positive radicals. So there is a list of positive radical, how many electrons they lose normally in a bond formation. Same way, the number of electron gained by a single oxygen atom in each of these cases is 2. So valency of oxygen is 2, and now this compound is called as aluminum oxide. Aluminium oxide. Now see, suppose I would not have framed or explained you this, straight away if I tell you how to write down the formula of aluminum oxides. So what you do is you search in this list. Normally you should memorize also, but initially you can use the list, but through your practice you will come to know about, you will be able to retain that memory of valency. So aluminum over here, it is clearly given the valency of aluminum is 3. So I put it as 3, and the valency of oxygen, oxide means oxygen, over here is oxide O, 2. So I put capital O and 2. Now only thing is that you just exchange the radical and write the formula Al2O3. So this is the way we write, cross multiply the valencies and write. So later somewhere a little processing is needed, but here aluminum oxide formula is this. Alright. So same way, suppose I have to write aluminum chloride. Suppose I have to write aluminum chloride. Now same way, chloride. So what we will do is we will pick up, already we know the valency of aluminum is 3. We will try to go to search chloride in the negative radical. Here it is 1. So chlorine, the valency is 1. So what will happen? Cross multiplication, Al1Cl3. But what happens? 1 normally we don't mention, it is understood. So it will become AlCl3. So this is how we write the formula of chemical compound. Very, very important. The process also is almost the same. There are other type of bondings also. So I will try to explain to you. Other type of bondings also are there. So I will try to explain. Have a look. Hydrogen. Now hydrogen needs to complete its duet, because it needs to become like, so it has got an electron over here. The valence electron of oxygen is 1, outermost valency, and oxygen has got 6 electrons in its outermost orbit. So what will happen? Now this oxygen needs 8 electrons. So what will happen? It will ask one more hydrogen to come near it. Alright, and then what happens? A sharing of electron takes place. So these are the 6 electrons of oxygen, and this is the electron of hydrogen and hydrogen. Now what happens? Oxygen will overlap its orbit, and now it has got 8 electrons, 2 to 4 to 2 to 4 to 6 to 8. These are called lone pair. These do not take part, they do not take part in the bond formation, and these are the electrons which take part in the bond formation. And hydrogen has made its duet. Later on I will tell you this is not pure covalent, this is partially covalent, but when we will try to explain the further parts of bonding, I am going to give these things in very small doses. So teachers, do not get excited if some teachers are watching. Things to be given to the students should be given in correct pace and correct dose. Alright. So now what is happening? The formula is H2O. So this is a covalent bond formation. Actually later on you will know that oxygen being more electronegative will pull the shared pair of electron and then develop small polarity. But the main gist is, what I am trying to talk is how many electrons are involved in sharing, and the number of electrons involved in sharing by a single atom is known as covalency, and the number of electrons lost or gained during a bond formation is known as electrovalency. So in totality, if we explain valency, valency means the number of electron lost, gained or shared by a single atom during bond formation. So Now suppose I had not given you, this is dihydrogen oxide. So the formula of water, if somebody has to write, then you know that water involves hydrogen and oxygen. So valency of oxygen is 2 and water is 1. So you can cross multiply, so it is H2O. We don't write 1 because I told you, you can write it this way and then later on rectify that it becomes H2O because 1 is hidden. So H2O, this is the formula. So now basically once you have understood the trick for writing formula, so now straight away we can go and try to learn how to write formulas and some basic things in formulas we should learn. Now we pick up some of the compounds which we can take at random. Suppose somebody tells me to write, say for example, sodium oxide. So what we do is, we know sodium is Na and oxygen is O. Obviously for the beginners you have to have a look on the list, and this list now should come in your memory. It is not very tough, very few, because entire chemistry you need these formulas to be in your in your mind and correctly, because you cannot write zinc chloride as ZnCl, you have to write it as ZnCl2, and you cannot write sodium chloride as NaCl2, you have to write it as NaCl. You cannot just memorize one that NaCl, sodium chloride is NaCl, so zinc chloride will be ZnCl. No, the valency of zinc is 2, so it will be ZnCl2. That is why this particular list with the valency is very important. So I am trying to recall, valency of sodium is 1 and valency of oxide is 2. So we cross multiply, so it will be Na2O. 1 nahi likhte hain, you know that we don't write 1. So children, now let us go ahead with say for example, we have to write say for example, next question comes is calcium hydroxide. Suppose we write this, or we write calcium carbonate. So calcium is Ca and carbonate is CO3. Now we know the valency of both of them is 2. So in most of the cases when they have same valency, you don't have to write, because the 2 will cancel out. So it will be calcium carbonate straight away, because both of them are the same, you can cancel out by the table of 2 when most of the cases when the valency is similar. Alright, now we move to more valencies, more compounds. We move to aluminum sulfate. Say for example, it is very, very nice to involve aluminum and learn this. Aluminum sulfate. Anybody from the board, can you tell the valency of aluminum? How much is it? Anybody from the group of students, what is the valency of aluminum? Can you tell? If you can see the list and you will come down over here. So what is the valency of aluminum? 3. So valency of aluminum is 3. Can you search out sulfate? It must be that side. Till that time I am writing sulfate. 2. So the valency of sulfate is 2. So it will be aluminum, cross multiplication we will do, aluminum sulfate. So sulfate is a group, no, a group of atoms. Now sulfate, you have to multiply by 3, no. So sulfate you have to put in bracket and put 3. So this is aluminum sulfate. So we have to be very, very careful while writing the group of atoms. You have to put a bracket always. Alright, now when we go to ammonium, say for example, I am trying to say ammonium carbonate. Then what will happen? Ammonium is a group of atoms, and then carbonate is also a group of atoms. The carbonate valency is 2 and the ammonium valency is 1. So what will happen? There will be cross multiplication. So 2 comes to ammonium. So there is a cross multiplication. So NH4, now this should come in bracket because it's a group. 2 and CO3, since you have to multiply by 1, so you don't give the bracket. So this is ammonium carbonate. This way through the list we can frame up a lot of compounds. Now next one is, let us have a look. We have to frame, say for example, We have to frame, say for example, calcium phosphate, calcium phosphate, calcium phosphate, phosphate. So calcium is Ca and phosphate is PO4. So phosphate's valency is most probably 3, yes it is 3, and calcium is 2. So here what we do is cross multiplication, but this is a single atom, so it will be Ca3 but PO4 and then whole twice. So this is calcium phosphate. Did you understand, children? So this is the way to go. Now there are a few things, remember, some of the atoms or radicals will have, some of the atoms will have variable valencies. Now which are the one we should pick up? First is copper. Cuprous, Cu, if they say cuprous chloride, we have to take the valency of copper 1, and if they say tell you cupric chloride, we have to take the valency of copper 2. Now remember, us is the lower valency and ic is the higher valency, upper valency. So if I have to tell cuprous chloride, sometimes it's easy. We have to tell cuprous chloride. Say for example, we have to tell cuprous chloride. Cuprous chloride. Chloride. So cuprous chloride means what will happen? Let us have a look. Cuprous chloride. So Cu and Cl. Now cuprous valency I said 1 and chlorine valency I said 1. So it will be CuCl. Alright. But if I say cupric chloride, then it will be Cu and Cl. So valency of chlorine is 1, but cupric is higher valency. Us is 1 and ic is 2. So it will be CuCl2, because cross multiply means copper gets 1 and chlorine gets 2. Same thing is with ferrous and ferric. Now here ferrous is 2. The valency of ferrous is 2 and ferric is 3. Alright. But here we can write, suppose they say ferric, say for example oxide, suppose they say ferric oxide, then ferric is 3 and oxygen is 2, then it will be Fe2O3, the cross multiplication part, have a look. But this compound nowadays is called iron 3 oxide. So already they give you the hint that use the valency of iron as 3. Then it becomes easy. They are already telling use it as 3 and then 2. Same question in different way you have to memorize that iron 3 oxide. Nowadays, to clear it up, because the children may not be able to know, they use this iron 3 oxide. And if I say ferrous sulfate, then what will happen? FeSO4, both the valencies are 2, so directly if we cross multiply, first it is Fe2SO4, but both the valencies are 2, so directly they cancel out, so we write ferrous sulfate. This the same thing is with stannous. Stannous is 2 and stannic is 4. Plumbous is 2 and plumbic is 4. Say for example, one or two more valencies I will teach you. That is, say for example, potassium dichromate. Potassium dichromate. Potassium dichromate. So what we will do? How we will write potassium dichromate? Potassium dichromate will be K and here it is Cr2O7. So the valency of dichromate is 2 and potassium is 1. So it will be cross multiplication, it will be K2Cr2O7 whole 1, but 1 we don't write. So this is potassium dichromate. This is how we go about writing the valencies and writing the formula of a compound. This is the list, students. We will be giving you the practice. and we'll give you the names of some of the compounds, and you should write the formula of those using this list, which I am going to add up in this same video. Thank you.